Hi, in previous sessions, we have developed baud clock generator and tested it as well. Now we are developing the second component of our UART project, which is serializer. So first, we will understand the high level concept of serializer, like what it will do and how it works, and how we will code it and test it. So look at this simple block diagram first. This module has load input and DIN input. They are marked with the red color. Now, when we assert this load input to our module, then this DIN input will load into the shift register. So question is, why we need shift register? Because this DIN input is a parallel data, but RS-232 protocol uses serial communication. So we have to convert this parallel data into the serial data stream. And then this serial data will be transmitted over the RS-232 protocol one by one in a sequence. So when we assert this load signal, then this DIN data will be captured by this shift register. And now we have to convert this data into a stream of serial data. So to achieve this, we have to shift our capture data one by one. And for that, we will use one another input, and that is shift enable pin. Means when this shift enable pulse is given to our shift register, then our shift register will shift and rotate its data by one position. And we have to rotate our data to the right. Now the question is that why we are rotating data to the right, not left? Because RS-232 protocol transmit the least significant bit first, means LSB first, and then it transmits the MSB in the last. So what we will do that we will transfer the least significant bit of this shift register, and once it's transmitted, then we will replace this LSB with the next transmitting bit. Means we are always transferring the same index, but we will override the content of that index with the next transmitting bit. So we will shift the registered data to the right for each shifting pulse given. And we will repeat this process until all the bits get transmitted over the RS-232 protocol. Now because we are shifting our shift register data to the right, so we have to insert some data at the MSB, right? So we will insert 1 at the MSB of this shift register data. Now the question is that why we are inserting 1 at the MSB, not 0. And the reason is RS-232 protocol standards. Because at the ideal state means when there is no data transmission happening, RS-232 protocol remains at logical high. So until we have the data to transfer, it will send the bits one by one. And once all the bits are transmitted, then this inserted value 1 will reach at the LSB position. Means now our module will be in ideal state. Because when all the data bits gets transmitted, then all of these bits will be replaced by logical 1 as we are inserting this value every time when LSB bit is shifting out. So remember this, we need to insert logical 1 when we are using RS-232 protocol like this. Now we need to understand that our data bits will transmit and our shifting operator will trigger when we give a pulse at this shift enable pin. So this shift enable pin will be derived by the baud clock generator, which we have developed in our last session. So this is the whole process behind this serializer module. Let me quickly brief it. We have these three inputs: load, DIN, and shift enable. And we have one output, DOut. Input DIN is a parallel data and output DOut is a serial data. So we need to convert our parallel input data into a stream of serial data. And that will be achieved by this serializer module. So when this load pulse is given, this D in data will be captured by the shift register. Note that this load signal will be only given for one pulse only. So once the input data is captured by the shift register, this load signal will be deasserted. And once you deassert this load signal, then your input data will not be captured. Means if you change this D in data after it, then the new data will not be considered in the current transmitting sequence. So our transmitter should still transmit the captured data only. This is little confusing. So let me repeat it again. D in data will only be captured until this load signal is applied. And once it's captured and load signal is deasserted, then the shifting operation will start on the captured data or the registered data, not on the D in data. Okay. Now for the shifting operation, we will use this shift enable input. And when this shift enable pulse is given, then the least significant bit or LSB will transmit out from the serializer module. And we will get the LSB at this output D output. And at the same time, when this shifting operation is happening, we will insert logical 1 at the MSB of our registered data. And once all the bits are transmitted, then this register will only have default state, means logical 1 at all the indexes. Okay, so that was a simple visualization of a serializer module. In the next session, we will write the VHDL code for this module. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.